Hello, this week we are going to focus on water quality data, and we're actually going to use two different data sets. One is from the Alaska DEC, which is the Department of Environmental Conservation, and one is from the Chesapeake Bay area. The DEC one focuses on Ketchikan, and Ketchikan does have a watershed plan for bacterial management. So they are monitoring bacteria that gets put into the waters outside of Ketchikan, and you can see seagulls here, which do contribute to bacteria within the water. This data set, I only was able to get 2019 and 2020, so it's a limited data set. There's not a whole lot that we can do with it, but we can look at it a little bit and learn some tips and tricks, and then we'll move on to the Chesapeake Bay area, which has a data set going back to 1984. It's a huge data set, and there's a lot of cool stuff that we can do with this data set, since we have data over a long period of time, and spatially it's also got quite an extensive coverage. But if you're not familiar with the DEC, you know, Department of Environmental Conservation, here's their website. And they have a beach program, which is where I got this data from, where they do monitoring of beaches around the state of Alaska. This looks like it could be on the Kenai, people dip netting off of the Kenai, which bacteria is definitely an issue there. And in this report, I can put it in the folder for this week's exercise if you're interested to just read about the background, if you want to, for the Ketchikan area. It looks like they've been monitoring maybe since 2017, but as I said, I didn't get all that data. One thing, you know, when you're making maps in ArcGIS, you know, it's part art. You can have little symbols that you can import, like dog poop contributes to a lot of these beaches. I always cringe when I see dogs walking along the beach because there's a lot of nasty stuff in dog poop. Seagulls, and then humans, which is a little bit disturbing, but they're testing for potential sources there. And so you have this document. With the Word document here, I tried to walk you through the steps that we're going to do. Again, if I deviate a little bit from the Word document, don't worry. There are many, many ways to do things in ArcGIS. So just kind of watch the video, and you can try to follow along with this too. The big thing with the Word document is you have questions in here, and so I would like you to answer these questions. Please put in bold after it, what is your response to the questions here, and you'll find them scattered throughout the document. Please make sure that you answer all of them. And if we go to Blackboard, you will see Blackboard here, and then you can find the information under course content is where you can find the folder. I will have a folder here called water quality where you can download the information. Actually, I think I'll do that right now. Alright, you'll now see a folder called Water Quality. Click in that, and you'll see that you have the DEC data and you have the Chesapeake Bay data. I'll probably make this video for the DEC data, and then I'll make another video for the Chesapeake Bay data, and you'll find them within this folder. So what you'll do is you'll click on the zip file. It'll ask you to download it. You know, I always recommend on your C, have a GIS. And you could call this water quality. Save it in there. Do the same for the other file. Okay. And I use Firefox for all my downloading, and I can easily see with this download arrow that there it is. Click on the folder. It'll navigate to your folder. So when you have the zip files downloaded, right click on them and say extract here. Right click, extract here, and there you go. If you just double click on these, it sends you to like a temporary type of place. You're not extracting them if you double click on them. So you always have to right click and say extract here. If you have 7-zip, you can go there and say extract here. But the key is extract here to a real place that you can access. Okay, so let's start up Arc Pro. And it's always good to make sure that your Arc Pro is up to date, because if people create things with newer versions, sometimes you can't open them with older versions. Alright, so I'm not getting any little warning signs that says I need to update. So I'm going to create a blank map. And I'm going to navigate to, you should always have a folder in your GIS called projects. So I'm going to go to my projects folder. And then I'm just going to click OK. And I'm going to call this water quality. And I'm going to hit OK. All right. So we have a blank map here, and let's go and add our data. I'm going to navigate to that location. Water quality. Let's start with the DEC data. So we have a geo database. This contains more information than you need, but for right now, let's add the pathogens, the fecal 2019 to 2020, the enterococci, maybe that's how it's pronounced, and let's add the hemline. So these 4 data sets, shape files, let's add to your project. Okay. You can see this hemline is the beaches actually for the whole state of Alaska. So if you're interested in other beaches, you could use this to explore data for other beaches. We will go down to Ketchikan here. And I always like to look at my attribute tables. So beaches. This really doesn't have any information about contaminants, but it does give you the name and the beach ID, which are very important because a lot of the information is collected by beach ID, and so this would be the joining field right here. So if we go and we look in the Ketchikan area, use the select, I can see that this beach is called KB Refuge, and let's see which of these data points is there. Oh, so this one is here, and you can see we have 36 samples, and here it's just called refuge. So that's, you know, the names can differ, and that's why it's always good to have this kind of beach ID, which the beach IDs do not differ. This hemline is kind of the statewide database. This is a local database that they use in Ketchikan, which is probably why they just shortened it to refuge. So if we tried to do a join between these 2 data sets, it would fail if we did it by name, but it would work if we did it by beach ID. But we know that this, say, point is associated with something called the KB Refuge. Okay? All right. So I'm just going to close these and hit clear. Okay. All right. So I'll move this to the side, and we'll walk through looking at this data. All right. So we have these added here. So let's first look at this pathogens one. This one actually contains data for both contaminants, bacteria, so fecal coliform, and the enterococcus, which is also the enterococci. And it has, I noticed these -99s. That's a common no data field. So we don't want to display the -99 data because it'll warp our results. So we want to set a definition query to hide the -99 data. So to do that, we go to this data set, click on it, then right click on it, go down to properties, then go to definition query, and we're going to add a new one. And so we want to exclude, I don't know why this thing is always so huge, more manageable here. We want to exclude the results values when they're equal to 999 minus 99. So we want to show the results values when it's not equal to minus 99. So everything besides 99. We'll hit apply and then hit OK. And oh, I see that now we've gotten rid of that no data of the minus 99. So that's good. All right. The other thing, that we notice when looking at this is that it includes information for both bacteria. So both the fecal coliform and the Enterococcus. So we just want to look at one. Let's look at the Enterococcus first. So let's go back to our definition query. So right click on it, go down to properties, and let's edit it. So in addition to wanting to exclude the no value data, let's only look at this Enterococcus. So go to add a clause and then choose name is equal to the Enterococcus. And hit apply and hit OK. The green check mark means that the query is active. Alright. So, alright. We sort this just to make sure we don't have any fecal coliform in there, and we don't. Alright, so now we only have this type of bacteria. So I want to visualize how this type of bacteria looks. So I'm going to turn off this other layer and only have our pathogens, and which beach has the highest amount of bacteria for this specific type. So let's go to symbology. And let's do graduated symbols here. So it'll make the sizes of the symbols larger, the larger the value. And we really don't need all of these decimal points. That's one big pet peeve of mine, is people who make maps where decimal points go out to infinity. No. So let's change it. Go up here to advanced options. And let's go to format labels, and let's drop this down to 1 decimal point. Okay. I'm going to go to 2. Let's try that. Let's take a look. And in this case, it looks like a very narrow range of values was found. So let's look at our attribute table. Oh, I know why, because we didn't select results values. So let's go back to symbology. And we're not doing latitude and longitude, we're doing results values. Ah, that looks much better. So a much bigger spread here, and again, go up to format data labels. I'm looking at the data. We go from 0 to 375, so we probably don't even, let's just leave 1 decimal point. So we'll go back. Okay, so our maximum value is 374, and we have 0 in some beaches. Okay, all right, so I'm going to zoom to the layer here. So go over to the layer, right click, and go zoom to layer. This shows the full extent of our data here. And since each of these points has multiple samples to it, that's why, like for this one here, you see multiple size rings, because sometimes the value was smaller, sometimes the value was bigger. So if I zoom out and go up to select, let's select this point. Let's take a look at it. Go to the attribute table. Okay, I see it was selected 8 times. Let's choose to show only selected records. Okay, and the values range to, sometimes it was 0, sometimes it was 10, and at one point it was 52. So it's not surprising that water, quality values would vary over the time of the year. And it kind of looks like during May, when the water's colder, the values are a little bit lower, but then as things heat up, you get more bacteria in the water. So that kind of makes sense. Okay. All right. So I'm going to clear that, and then I'm going to go and show all the records. So using the data sort, you can sort by smallest to largest, and you can sort by largest to smallest. I want you to figure out what is the name of the beach with the highest values for the Enterococcus. So what is the beach that has the highest values? And then I want you to go and repeat this using looking at fecal bacteria. So what you'll have to do is you'll have to go to the properties of this layer. You'll have to change this to fecal coliform. Hit apply, hit OK, and then look at your attribute table. Alright, we're only seeing fecal coliform here. I'll sort descending, sort ascending, okay? And then you're gonna go back to look at the fecal coliform, look at the properties, or sorry, go to symbology. And what I would do is just click single symbol to kind of reset your symbology. Then go again to graduated symbols. Make sure you choose result value. And I'm going to change the decimal points again. I can highlight it and just hit the number 1. That's the faster way to do things. And these values range from 0 to 138. So what is the beach that has the value of 138 for its count of fecal coliform bacteria? So please answer the following questions for this exercise. What's the highest value for the Enterococcus, and what is the highest value for the fecal coliform? All right. Once you do that, let's take a look at this database that has data from 2019 to 2020. So we have 2 years of data here, and one thing that we can do is we could look at the data over time. So I'm going to turn this layer on. I'm going to zoom to the layer just to see the extent of it. Okay. And I'm going to open up the attribute table. Okay. See the attribute. Now there are 2 year columns in here. The first year is a long field, so it's a number. And the second is a text. Sometimes you'll see that. I mean, numeric attributes sometimes are treated differently than text values. Say if this database had several years of data, if it was a year was a text value, you'd have to select each individual year that you wanted to see in the data. If it's a numeric value, you can just select range, because you can treat it like a number and say, I only want, 2019 through 2023, should you have that data. So that's the reason why you might see multiple year columns in your database. All right, so first let's explore what this database looks like. I'm going to close this. With this selected, you'll notice that you have a data tab up here. We can make some charts and graphs actually right in ArcGIS. So go to data, then go to create a chart, and then go down to line chart. All right, you see nothing, but it says, select variables in the chart properties to begin. So we go over to properties here. And so we want to look at what is the Enterococcus look like over time. So here we have a field called date. Let's choose date. And we want to look at what is going to be the mean. And the field that we want to calculate the mean of is actually the result. And then hit apply. All right. It's binning by 3 weeks. That's okay. We could just accept that as the default. So then click off of it. Or close this down. And you can see this is what the data looks like going from June to October in 2019. And then what it looks like in 2020. You'll notice it's a lot lower in 2020. And so I have a question in there about, what is the difference between these years and kind of what might be driving the difference between these years. So just kind of comment on that. All right. One thing that's interesting is if you click on map and select, if I select these, notice it highlights, so you can see that these points are highlighted. So say I'm going to clear this again. Say I was interested in knowing where this beach is, when this beach was sampled. I could just highlight this single beach and I could see, well, this beach was actually sampled at every single point that we have on our graph. So this chart is actually linked to the data that you're seeing, which is pretty cool. So you'd be like, why don't I just do this in Excel? Well, I mean, because it can be related here. So, okay. All right. So there's how to use the charts. You can do the same thing with the fecal bacteria if that is highlighted. You can go up to data, create chart, and we can look at this one again, this line, and go to properties, then go to date, and go to mean. And for this one, I want you to select fecal greater than 31. These are different cutoff criteria for exceedance values, and hit apply. And then again, just kind of close this, and you can see, you didn't really have the fall off in 2020 that you had in 2019. So, you know, maybe this bacteria isn't so much related by what might not have been coming into the Ketchikan area in 2020. Different patterns for different bacteria. One thing that's interesting, again, it was linked, is I can clear and I can hit select and I can say, where in the heck is this high data point from? So I can select it and it should show up. See if it is. It was before. Let's see. I'm going to select this guy here. It should show up. I'm not exactly sure why. Oh, okay. Because I'm dealing with the fecal one. I got to turn the right layer on. So it's always important to have your right layers turned on. So let me select this one now. Okay. So I selected this one now and I can see, okay, this one was sampled. This beach was sampled every single time. So let's try to clear this and let's try this again if we select this. Well, it selects every single sample because every single sample was done at that time and we're taking the mean. So if you did have single data points here, you could just select a single data point and figure out on the map where it is. Okay. So as I mentioned, this database, you know, this fecal and this enterococci, they have flagged when it's exceedance. So when warnings might go out to the beaches and say, you're closed. And we look at it and you have just the pure results. This is what the bacterial counts were. And then you have exceedance. So you can see this beach broke the exceedance for safety. And so a warning went out to people, you know, maybe not to use this beach at this time. So maybe you are interested in figuring out which beach had the greatest exceedance in 2019 and 2020. And so in order to do that, this is one of your questions. What we need to do is we need to count up the number of exceedance by year and by beach. So if we were going to join this, say to this beach line, we would use beach ID, but we're not going to join it, so let's just use the name because it'll make more sense when we look at the results. So click on name, right click, and go to summarize. So we want to summarize by beach name and by year, and what we're trying to summarize is the total count of how many times it exceeded the threshold set by the DEC. So our statistics field is going to be our exceedance, and we're going to count up the number of times it exceeds it. What we're summarizing by is the name of the beach, and we're interested in the variation between the 2 years. So it doesn't matter whether you select a year or year 2 in this instance, it's okay. And just save this to the default geodatabase, that's fine. And then hit OK. And it will run the summary statistics. All right, so look at your new table. Go right click and go to open. And the frequency is just tells you, okay, this herring beach was sampled 18 times in 2019, and of those 18 times that it was sampled, 6 of those times it exceeded the health safety standards. Okay. If we look here, let's see, this beach sampled 18 times and never exceeded the safety standards for this Enterococcus bacteria. And if you want to determine, one of your questions is, what is the beach that has the highest exceedance each of the years? You'll do an advanced sort. So go up just to any column, right click, and go to custom sort. It's actually called custom sort here. And sort by year, and then sort by name of the beach. And then for actually, you'll sort by year, and then, sum of exceedance, and you'll sort this as descending. So what we're doing is we're splitting out the years first, and then we're looking within the years. I want you to sort this from largest to smallest, and then hit OK. I'm going to clear my selection, and so now you can see in 2019, this is the beach that had the greatest amount of exceedance. So kind of flagged the most times of do not go here. I want you to tell me what is the most exceedance for 2019, and then what is the most exceedance, the beach that had the most exceedance for 2020 for the Enterococci. And then repeat the same process for the fecal coliform. So you go through the exact same process of opening your attribute table, clicking on, let's say, the beach name, going to summarize. Here, the field that you're going to summarize is going to be this fecal greater than 31. You want the name and you want the year. Just save it, to your default geodatabase, then hit OK. Then open up this one, right click, and then do the sort, the custom sort. You'll sort by the year, and then you'll sort by the sum, again descending, and this will sort it and give you the answer for the fecal coliform. What was the beach that had the greatest amount in 2019, and what is the beach that had the greatest amount in 2020. So you'll see those are the questions that you need to answer in your homework. And that's basically all that we're going to do with this data from the DEC. Like I said, there's not a whole lot of data there. So we can't really get into a whole lot of spatial statistics, but we can answer some basic questions as far as which beaches seem to be having a problem. And when you look at the beaches, you just kind of notice where they occur. Also, the beaches that do have problems, you can go to this Word document here, and if you scroll up, you can see what types of contaminations are contributing to the beaches that tend to have problems, or maybe don't have problems. And then maybe you can kind of decipher what might be contributing to the higher bacteria amounts within beaches within the Ketchikan area. But that's just kind of a short introduction to the Ketchikan water quality data. Next we'll move on to the Chesapeake Bay area.